Welcome. Today I am going to discuss about the wave nature of light part 2. We'll discuss only three topics. The first topic is the proof of the second law of reflection. Then the second topic is the proof of Snell's law. Third topic we have the optical part. We will go to the first proof. Okay. The first proof we have the proof of the second law of reflection. We'll consider a surface and we have the incident ray and the reflected ray. Then we have another incident ray. We'll mark some points. We'll consider the surface as S dash and AB representing the incident wavefront. A dash B dash representing the refracted wavefront. We have the angle of incidence and angle of reflection respectively. Now we'll use the Huygens principle, and after after a time t when the wavefront strikes the point A dash, the secondary wavelet from A has acquired a radius which is equals to A B dash equals to B A dash, which is equals to velocity times time. That is according to the Huygens principle. Okay. Now we'll use trigonometry. We'll find sine I. Sine I which is equals to A B dash from by A dash. Sine R which is equals to AB dash divided by AA dash. Now we'll divide sine I and sine R. We'll get BA dash divided by AB dash, which is equals to velocity into time divided by velocity into time. Now we got the value of BA dash divided by AB dash from the earlier equation. Okay, we have found that is according to Huygens principle. Now finally we'll get the ratio as 1. Sine I uh, now equals to sine R. Now, if sine I equals to sine R, then the angle also must be equal. So, with this logic, we get I equals to R. That is the angle of incidence equals to angle of reflection. So, that is it for the second law of reflection. Now, we will go to the second proof, that is the popular Snell's law. We have the surface first incident ray, refracted ray, incident ray, refracted ray 2, that is the second incident and the second refracted ray. We have the third incident ray and the third refracted ray. Here we're considering the three incident ray and three refracted ray. Right? So that is the medium one, the medium one and medium two. Now we can see from the diagram that medium two is much denser than the medium one. But why? Because the light is bending away from what it should go. That is, mean, it is bending towards the normal. Now we'll mark these points as that is the diffracting surface. Mark these points, and now we have the AB dash, which is the incident wavefront, and A dash B dash, which is equal to the refracted wavefront. We have the angle I and angle R. I means angle of incidence and angle of refraction. Okay. Then you can see that from here that when after time t, B A dash, which is equals to velocity into time, time t. V1 is the velocity in the medium one, and t is the time, and AB dash is equal to V2 into t. V2 is the velocity in the medium two. Okay. Now we'll use trigonometry and find sine I and sine R. Sine I, which is equals to the sine of A dash, which is equals to B A dash divided by A dash, and sine R, which is equals to A dash B dash, which is equals to the AB dash divided by AA dash. We divide sin I and sin R, you get BA dash divided by AB dash. Now sin I by sin R, which is equals to V1 by V2. We have calculated the value of BA dash, which is equals to the V1 into T, and AB dash, which is equals to V2 into T earlier. From there, we will cancel the T and get the ratio of sin I by sin R, which is equals to V1 by V2. Now, V1 and V2 are the velocities, respectively, in the medium. Now, that is not variable, that is constant. We'll write V1 by V2 is equal to constant. That means sin I by sin R is equals to constant. Sin I by sin R equals to the that uh, 1 in 2. What is 1 in 2? That it means the refractive index, that is termed as the refractive index of the medium 2 with respect to the fast medium, which is constant. Now, refractive index of second medium with respect to the fast medium, which is equals to the V1 by V2. We have found from these equations. Okay. And that is a proof of the Snell's law. Now we'll go to the next slide. Now the last topic, we have the optical part. Optical part is nothing, it is the product of n times d. N times d is, is called the optical part traveled by the light. Now, what is n and d? N is the refractive index of the medium, and d is the distance traveled, distance that the light ray has to travel. That is the product of those two, n and d, is called the optical part of the light ray. Now we have the proof of this optical part. If v is the velocity of the light in a medium whose refractive index is n, and according to wave theory, we have v is equal velocity which is equals to c by n, and c is the velocity of the light in vacuum. For traveling, and now for traveling a distance, the time taken by the ray will be given by t is equal to d by v. D is the distance travel and v is the velocity we have seen. Now we'll substitute the value of v here, and we'll get d by c by n. We'll equate this and we'll get t is which is equals to n d by c. At the same time, the distance traveled by the light ray in air or the vacuum is bigger. D is equal to c times t. We'll substitute the value of t we have calculated earlier, and we'll get t is equal to n times d. Clearly, a light ray travel a d distance in a medium of refractive index in the same time the light will travel in time d in the air. Okay, that is the optical part. And thank you for watching my YouTube video.